So welcome everybody to week 10. Week 10 is all about sequences. What's a sequence? What's another word for a sequence? Brilliant, a pattern. So we're going to talk about patterns today, but in a mathematical way. So the posh mathematical way for patterns are sequences. Sequences come in all sorts of shapes and sizes. We can talk about sequences with numbers, we can talk about sequences with shapes, talk about sequences with colours. A sequence to my title goes grey, green, brown, and so on. The point of today's lesson is to look at sequences and try and put them in terms of mathematics so that we can go to a sequence and find out any position within a sequence, what a value is. Okay? So our objectives for today's lesson, of which there are 3 today and tomorrow that we're going to cover, are to generate terms of a sequence using something called the term-to-term rules. That's a fancy way of saying we've got a sequence started. If you can spot the pattern, we're just going to carry that pattern on. The second one is find the terms of a sequence using position to term to define the sequence. So here we're going to start using a little bit of maths to look at the pattern, to define it, and to work out other positions within that sequence. And then the end of today, maybe the beginning of tomorrow, we're going to use mathematics where when we talk about the position within a sequence, we talk about this letter, this variable. You know, we've been using them up to now in basic algebra, called n. It's very specific in sequences. We use the letter n. So we're going to define these sequences using the letter n. So over the course of today and tomorrow's lessons, we're going to carry out those 3 objectives, and you'll be masters of sequences. Sequences, patterns. So anything that represents a pattern can be represented with these sequences that we're going to investigate today. And by the end of today, you will have an idea of how to examples of sequences. When we look at sequences and we look at them with numbers, we have straightforward sequences. The most simple sequence you'll come across in mathematics is probably counting 1, 2, 3, 4, 5, 6, 7, 8. That's a sequence. What am I doing with that sequence? How do I know what the next number along is? What is it that I actually do with this sequence here? We're adding 1. So every time, I'm just adding 1 to the one I had before. In a few minutes, we'll learn the proper term for that. That's called a rule. And the rule is I'm always adding 1. Okay? In this instance, it's a nice rule because all I ever do is add 1. Sometimes sequences aren't that nice. What's this sequence doing?
Doubling, yeah.
Sort of doubling. What's the difference here? What's the next one?
2.
And the next one?
3.
Okay. So again, it's a sequence. I can tell you what the next one along is, but this time it's not as regular as this. Today and tomorrow, we're going to be looking at both types of sequences. This one is called a linear sequence, where it does the same thing every time. We're always adding 1. This is non-linear. Okay? The good thing about the non-linear sequence, where it does all these funny things, is that we don't have to do anything complicated with them today or tomorrow. All we need to do is continue a non-linear sequence. All the clever stuff you're going to do today and tomorrow is to do with linear sequences, where they go up or down by the same amount. So, the first thing you'll be expected to do with a sequence, once you're given the start of a sequence, is to continue it by spotting that rule. Okay? So, what I'd like you to do is have a look at this, give you a couple of minutes, and tell me what are the 2 missing numbers at the end of the sequence. Use the show me boards and hold up 3 sets of 2 numbers, okay? So we've got 3, 6, 9 and 12. So what's the next one along? 15 and
18.
So what was my term-to-term rule? What's my rule here? Plus 3, yeah? We're adding 3 every time. So that is called a rule. That's a very specific thing. A rule is something you can put in writing. So what's my rule here?
-5.
Good. So if I'm -5 all the time, all I do is I go to the end of my sequence and I take away 5. So I end up with 16 and 11. Everyone get those? Phew. I've got 4, 2, 0, -2. What's my rule? -2. So I end up with -4 and -6. Continuing sequences might not involve numbers specifically, nice round numbers. You might get sequences with letters. A, C, E, G. What's the next one along? I. Why is it I?
Because you miss the H.
Good. So it's A, I'm missing out B, C, I'm missing out D, E, I'm missing out F, G, I'm missing out H, I, missing out J, and K. Okay? So even numbers can have sequences. Sorry, letters can have sequences. Numbers don't have to be round numbers to be in a sequence. So here I've got 1.2, 1.3, 1.4, 1.5, 1.6 to continue that sequence in decimals.
When that got to like 1.9, would it then go to 2?
Yes.
Yeah.
Yeah, definitely. Sequences can involve shapes. So I've got arrows, up, right, down, left. The next one will be up and then right again. So please don't get this image in your head of sequences just being about numbers. So spot the pattern and fill in the blanks. So rather than spotting the pattern, spot the rule. So what's the rule for this first one? So if we add 8 and add 8 all the time, I know that this one is 31 and this one's 39. What's the rule here?
Minus. Oh, it's at 4.
What am I doing with 4? Something to do with
Adding
4. Good.
Yeah.
So if I'm at minus 11 and I'm going to minus 7, I'm going that way on the number line. So I'm adding 4. So to get the next one along, I add 4. So this becomes positive 1. This one becomes 5. So this is a way they'll check your understanding of negative numbers on sequences. So you're making sure you're going in the right direction, and then you switch from negative to positive. They love those. And then we've got 8, 5 and 2. So what's my sequence, my rule? Minus 3 is my rule. So I end up at?
Minus 1.
Good. Okay, minus 1 and minus 4. So again, we're going from positive into negative. It's another one of their favourite ways of checking your understanding of negative numbers. Okay? Right. So those 3 examples we've just done, the pattern is the rule. So plus 8, plus 4, minus 3. Sometimes the sequence doesn't have to be linear. So the rule might be a different rule, which means the numbers don't go up or down by the same amount every time. So here I've got a sequence. 1, 4, 9, 16. What are the next 2 terms in that sequence? We've got
25.
25. Chelsea's got 25. How did you get 25? You added 9. So basically, Amanda started it off. She said plus 3, plus 5, plus 7, plus 9. So the next one,
Plus 11.
plus 11.
Yeah.
So 11 plus 25. Does anybody recognise any of those numbers? So one rule, term-to-term rule, is add 2 to whatever the difference was last time, okay? But does anybody recognise those numbers? Do they look familiar? That's 1 squared, that's 2 squared, 3 squared, 4 squared, 5 squared, and 6 squared. So in theory, squared numbers have patterns, where the difference between squared numbers is plus 3, plus 5, 7, 9, 11, and it would carry on, okay? So can you see how that works?
Mm-hmm.
So the term-to-term rule could be squaring the next number along, or it could be adding 2 to whichever the difference was last time,
So
whichever
for
one you
that
want.
rule, could you write either of them?
Yes, and they would both be. Another one. Now this is one that sometimes appear, and people lose marks because they're not using maths expressions to say what's going on there. So what's happening there?
Times in there.
Itself.
Good.
Yeah.
You're timesing by 10. Okay? Somebody this morning said, I'm adding a 0. Now in mathematics, adding 0 to something does what? Nothing. Add 0 to anything. So if he put add 0 as his rule, he would not get a mark. See what I'm saying? So you have to be specific with your definitions on the rules. So the rule here is I'm multiplying by 10. So 10 times 10 is 100, times 10 is 1,000, and then you could fill in the blanks. Okay? Yes, the theory of it is you're putting another 0 at the end, so it becomes 10,000 and 100,000. But as a rule, if you say adding 0, that's not actually what you're doing, if you catch my drift. Yeah? Good. And that's one they like to catch you out with. Okay. The other way they're going to get you to continue a sequence especially a non-linear sequence, is give you a set of instructions to follow to get the next term in a sequence. So these are called terms, each of these numbers within a sequence. That's the first term, second term, and third term. Okay? So to complete a sequence, sometimes they'll give you instructions. These instructions look very familiar, don't they? It's saying double the previous number and add 2. Remember when we came across something like that a couple of weeks ago? Do you remember the function flowchart? Double the previous number means what?
5 times 2.
And then add 2 means add 2 to the next one. So in theory I'm doing 2 functions to my number. I'm multiplying it by 2 and then I'm adding 2. So I've got 5, multiply it by 2 to get 10, add the 2, I get 12. 12 times 2, 24, add the 2, 26. So you would just follow these instructions to work out the next 2 terms of your sequence. So 26 times 2 is 52, add the 2, gives you 54. 54 times 2, 108, plus the 2, 110. Okay? So can you see how they can create sequences from instructions? You happy with that? Good. So, I want you to follow these instructions and give me the 2 missing numbers on that sequence if you can. Let's do this. So what's my next value then? 28. So I'm trebling that to get 30 and then taking away a 2. And then the last one? 82. Good. So you're happy following instructions and completing sequences. Now this is quite important because one of their favouriteest questions in all the world for sequences is giving you a series of instructions to fill in the blanks like you've just done. So you've just given me those 2 answers. And what they'll then say is you come back the other way. They'll give you a sequence, a set of instructions, but you have to work out things backwards. So if we just leave that up there, and I say to you exactly the same, treble the previous number and subtract 2. If I say to you, 10 is my third term, so 10 is my third term, what's the first and second term? I need to come back the way. So earlier on I did this. I said we multiply by 3 and we subtract 2. And I said it was very similar to a function machine. You do it the opposite. So you start with 10 here and you come that way. So you add 2 to get 12 and then you divide by 3 to get 4. So can you see coming the other way, I can go from the 10 to the 4. And this is one of their favourite questions in sequences. And that is coming the other way from a set of instructions. Okay? So I'm going to give you a chance to do one. Double the previous number and add 4 is your set of instructions to fill in a sequence. However, the only thing you've got to go on is the fact that the third term is the number 16. What are the first and second terms in that sequence? What are my functions? If I'm drawing my function flowchart, what are my 2 functions when I'm going this way?
Times by 2.
That's my first function, and then add 4. So really, we're coming back the other way, so we need to
Take away 4.
and
Divide.
by 2. Okay? So when we feed 16 in here, I subtract 4, I get 12. Divide by 2. So my second number is the number 6. Can you see what we've done there? I've now got 6, so I stick 6 into my function flowchart. I come back the other way, I end up with 2, and then I divide by 2, 1. So there you go. So I can start anywhere in a sequence and work forwards or backwards on my instructions. You see how that works? Yeah? And that, like I say, they're really, really popular questions. Good. Good, good, good. Okay, the next thing that they're going to ask you to do is to complete a sequence where you've got gaps in a sequence. So you need to fill the gaps in the sequence. So what number lives in here? 11. And how did you get that, Chelsea? That's good. Good, so there's 6 between there. Perfect process is exactly what I'm going to teach. And half of it, yeah, in the middle of it. So half of it, because I've got 2 steps, so I divide this by 2. Each step is worth 3. See what I've done there? So now I know what my step is, plus 3, plus 3, plus 3. I can stick that one in there. Let's use that exact same process for this one. Okay? So I've got 20 and I go to 4. What have I done? Minus how many? 16. I've gone down 16, so I've got minus 16. How many steps do I have to get from here to there? 4 steps. So,
16 by 4.
16 minus 16 divided by 4 tells me that each step is minus 4. So I take away 4, I end up with 16, 12, 8. Can you see what I've done there? So to work out what's in between things on a sequence when you've got gaps, you work out the difference to your gap and then you divide it by the number of steps for that gap. So here it was nice and straightforward, a gap of 6 divided by 2 steps. Here it's a gap of minus 16 divided by 1, 2, 3, 4 steps. Minus 16 divided by 4 tells me I need to minus 4 on each step. That's my rule, minus 4. You happy with that? Yeah, nice and straightforward. There's 3 to have a go at. So, nice easy one to fill in the gaps, a bigger gap to fill, and then this one's a tricky one because you've got a gap to fill there, but then you've got to apply what you've learned the other way as well. Let's do these then. So for the first one, the gaps are here, there and everywhere. All you need to do is just choose one gap. So, what's our process for doing this then? 30 to 19 is a gap of plus 6. Yeah. How many steps? 2 steps. So divide plus 6 by 2 and it tells me 1 step is worth 3. So you end up with 16, 19 and 22. Happy? Good. I've got 52 down to 40. So what's my gap? Plus, minus 12, sorry. Minus 12. Let me use the board properly. I've got a gap of minus 12. How many steps?
4.
Got 4. So minus 12 divided by 4 tells me each step is worth minus 3. So I take away 3 from that, end up with 49, 46. Everyone get those?
Yes.
Yeah? So these gap ones are quite straightforward. The next one, concentrate on the gap that you can do something with. So I've gone from 6 to 27, I've got plus 21, and I divide it by how many steps?
3.
Yeah, 1, 2, 3. 21 divided by 3, 1 step is worth plus 7. So 13, 20 and 27. If it's plus 7 that way, what have I got to do this way? So I end up with, just to show you that sequences also apply to shapes, quite frequently in the exam, they will give you a sequence of shapes. A sequence of shapes is just like a sequence of numbers. It goes from 2 to 4 to 6, so how many would be in the next one? 8. I'm not going to draw. They can give you L shapes. So you've got a shape here, a shape there. So what will the next one look like? How many up will it be?
5.
5 up, so we'll have 1, 2, 3, 4, 5, and then how many across the bottom?
4.
Okay, so it looks something like that. They can quite easily give you something like this in the exam. I know it sounds daft, but what we're going to do next on defining sequences can be done for shapes. So all you have to do to get from a shape to defining a sequence is numbers. 1, 2, 3, 4 of them, 6 there, 8 there. So I've got a term-to-term rule of plus 2. So now we've got to the end of the easy bit. So I'm going to give you 2 questions from past papers to do with the easy stuff we've covered so far. So here it says fill in the blanks. Okay, exam question, the number in the sequence decreases by the same amount. What are the 2 missing numbers? So we can see our term-to-term rule based on some of the numbers that we already have on our sequence. So what's our term-to-term rule? Minus 8. So all we need to do is apply that rule here, and I end up with clickety-click. And then if I apply the rule there, how many marks do I get in the exam for that?
1. 1 because you've not put it on the answer line.
I haven't put it on the answer line. So if you don't put 66 and 34 there, you won't get the marks. If you go like that, you won't get the marks. Unless you write 66 and 34 on that answer line, you're throwing away marks in an exam as a pass mark of anything up to 80%. There you go, that's the second part of the same question. Still November 2010, question 8b. Okay? The numbers in the different sequence decrease by the same amount each time. 26 down to 6. So, what's my starting point to solve this one then? Good. So, to get from there to there, I've got a distance of plus 20. And how many steps have I got to make up? 4. So I've got plus 20, divide it by 4, tells me that each step is worth, sorry, minus 5, isn't it? It's not plus. So it's minus 20 to get from 26 to there, so it's minus 20, divided by 4 means we're going to minus 5, okay? So 26 minus 5 is 21, 16 and 11. Again, if you leave it like that up there, you're throwing away 2 good marks, because if you don't write 21, 16 and 11 down here, you're not going to get the marks on the answer line. Okay. So now we're going to start getting onto the trickier stuff. Okay, so we've got our sequences. The place in a sequence is called a term. I discussed this earlier. Okay, so I've got a sequence 2, 4, 6, 8, 10, 12. Nice easy sequence. The first term, in other words, the first number in my sequence is 2. If I jump down my sequence, my 6th term, the 6th number in my sequence, is the number 12. So with any sequence, it's got positional values, okay? And they're called the terms. They're the place in the sequence. So the term, fancy word, so we've already had the rule. We've got something called the term. And the term is the position within the sequence, okay? So we can talk about something within a sequence by referring to it by its term. So the 5th term in that sequence is what?
I'm going
1, 2, 3, 4.
15.
Okay, 15. So the 5th term in our sequence is the number 15. It's what is in position number 5. The 2nd term in this sequence, T, which stands for Tuesday. Monday, Tuesday, Wednesday, Thursday, Friday. Another sequence. Okay? So when I said to you at the start of the lesson, our first objective was to mention the term to terms of a sequence, it's a fancy way of saying how do I get from one term to the next. And that is something we called earlier called the rule. Okay? So the first objective, the only thing the first objective is about is continuing sequences or filling the gaps in the sequences. They're using fancy words called term to term of sequences. All you need to know is the rule. So the rule for this one is plus 2. And the term to term rule is add 2. The term to term rule is subtract 4. And then they get you to complete the sequence or fill in the gaps of the sequence or follow the instructions. Okay? So that is the first objective done. So that was a fancy way of saying fill in the gaps or continue with sequences. We're going to move on to the tricky maths alert. Okay? This comes with alarm bells, warning signs, health warnings and everything. What we're going to do next is only to do with linear sequences. Sequences that always go up by plus 2 or minus 3 or whatever, okay? In order to define a sequence, we need to talk about this position value, this term. Where am I in my sequence? And at GCSE level or any level of maths, in sequences, when you don't know where you're going to within your sequence, we use the letter N, and that's the little letter n, not a capital N. Some people put capital N's, it's a different thing. A big N is newtons. A little n is a number in a sequence in mathematics. So it has to be a little n. And when we define where we're going to in a sequence, we talk about this nth value, this n. Okay? So if we look at our basic sequence, 2, 4, 6, 8, 10, 12, we know this is the first term, second term, third term, fourth term, and so on. All n does, instead of using windy language and saying the first term is this, we just say n is 1, n is 2. So n relates to the positional term. Okay? So if I say n, what is it? N is 6, you go to 6 and you can see the value of 12 is at the 6th position. So all the letter n is in mathematics is a fancy way of saying what position within my sequence am I going to. If I don't know where I'm going to, I leave it as n. As soon as I make n a value, like n is 6, I just go to the 6th value in my sequence, which is the number 12. Okay? So this letter n is a short way of saying my position within a sequence, my term, which term am I going to. Okay? So, dividing a sequence in algebra, we need to talk about this letter n. But like I said earlier, at this level, in foundation level maths, we only ever have to do that. So, linear sequences go up by the same amount.
Excuse me.
2, 4, 6, 8 is a linear sequence because I'm always adding 2. 1, 4, 9, 16 is not linear because it goes up 3, up 4, up 5, up 7 and so on, okay? 22, 17, 12, 7 is a linear sequence. It's going down by 5 all the time, okay? So this process I'm going to show you for defining a sequence only applies to linear sequences. We cannot apply it to non-linear sequences. So, in order to define any value within a sequence, I need 2 bits of information. If we look at one of our straightforward sequences, what do you think the 2 pieces of information I need to know to define my sequence are? Think about what we've talked about already. What's the 2 most important bits of information about that sequence?
So we're looking to the real.
The rule. So the first thing that's really important is the rule. So in order to define my sequence, I need to know what the rule is, the term-to-term rule, what's happening, okay? And in this case, I'm always adding 2. What is the second most important thing of that sequence to define it? Do you reckon? So we know the first term is the most important number. So with 2 tiny bits of information, I can define any linear sequence of numbers, and that's what I'm going to show you in a minute, okay? Just using the term-to-term rule, the rule, and whatever the first term is. And we are, by the end of today's lesson, going to be able to go into any linear sequence and pull out a value at that position. Okay? So that's what this is about. This is kind of fundamental to sequences. So, let's look at a sequence, 2, 4, 6, 8, 10, 12. My position number, so n, my term, that's my first term, that's my second term, that's my third term, that's my fourth term. What's my term-to-term rule? Plus 2. Can you see a relationship between this number here for my position and this number here for my value in the term?
It's going up 1.
1, 2 is 2.
Good, 2 2s are 4, 3 2s are 6. So there's a relationship between that number 2 and the fact that I have to multiply that by 2. Okay? And that's a relationship in mathematics. And what it means is, if I multiply my position, my letter n, by my rule, which is plus 2, I don't put the plus in, I just call it 2, it tells me what value's in that position. Look, if I go to my 6th term, so I swap the letter n for the number 6, 2 times 6 tells me the value 12 is there. If I went to my 100th position on my sequence, I swap the letter n for 100, 2 times 100 is 200. So I don't have to write this out 100 times to get to that value. I can jump straight to my 100th position and work out that the value that's sitting there is the number 200. Okay? So, let's look at another one, just to prove this rule that we've just come up with. So, what is my term-to-term rule here? What am I doing between these numbers? I'm adding 3. So if I apply my rule to my position, my letter n, it's telling me that my position to value is 3n. I multiply the rule by the letter n. So if I go to my 6th term, 6 times 3 is 18. So I can define that sequence using the expression 3n. Because I can go to the 5th value, 3 times 5, tells me that my 5th value is the number 15. Okay? So we're defining any number in a sequence based on the rule. That's the first bit. Okay? So the first part of our expression is that we multiply this positional value, n, by the term-to-term rule, whether it's positive or negative. Okay? So let's try it. You do those three for me. Tell me what the nth term is for each of those sequences. So look at the term-to-term rule, and you multiply the position, the letter n, by that rule. Okay? So the first one then, 4 to 8, what am I doing? Adding 4. So what does that tell me my nth term should be? 4n. You take your rule and you multiply the position by 4. So if I say, what is my fourth term? Well, 4 times my position, 4, is 16. I go to my fourth term, and lo and behold, I've got a 16 there. If I said, what's my 50th term? 4 times 50 is 200. I don't have to write it out. I can go straight to the position of 50 and know that the number 200 is in that position. Let's do the same here. I go from 5 to 10. So what's my term-to-term rule? Plus 5. So the nth term is 5n. They're different things. That's the rule. That's the nth term. People always get these two things confused in the paper. So when you get your practice, your assignment for this week, when you look at past papers, if they ask for a rule, you give them a rule. If they ask for an nth term, you give them an nth term. Okay? People always confuse the two. Don't. Rules are wordy things. Add 5. Nth terms has the letter n in it. Okay? Good. So if I go to my fourth term here, I swap the letter n for the number 4. 5 fours are 20. It tells me in my fourth position I have the value 20. The last one then. What's my term-to-term rule? Plus 8. So it's 8n. So if I go to my fourth term, 8 times 4 gives me 32. So we've defined the first part of our sequence by saying whatever our rule is, we multiply the position by that number. However, it's not that easy because there's sometimes a difference between your rule and the first number in your sequence. All the examples I've given you up to now, I've made them nice and easy so they tie in nicely. However, sometimes your rule is different from your first term. Let me show you. We've got a sequence, 3, 5, 7, 9. So what's my term-to-term rule? Good. So it's plus 2. Okay. So if my sequence is plus 2, it means that I've got a sequence definition of 2n. Yeah? Our nth term. Because what we do is that plus 2 we multiply by our position. However, for position number 1, I multiply 2 by 1, I end up with 2. I don't want 2, I want 3. So I have to do an adjustment. So what do I need to do?
Is it 2n plus 1?
It is absolutely 2n plus 1. So the expression that defines this sequence is 2n, because that's the rule, times n, with an adjustment of plus 1, because I'm at 2 and I need 3. So let's have a look at it. Let's go to our fourth term. I put 4 in here. 2 times 4 is 8, plus 1 is 9. Works. I can go to 9. What's my 100th term? I don't want to write this sequence out. 2 times 100 is 200, plus a 1, 201. I don't have to write out 100 numbers to get to my 100th term. I can leap straight to my 100th term by swapping n for the number 100. Okay?
That's the nth term.
And this is what we call the nth term for that sequence. Okay? Let's have a look at another one, just to check our rule, okay? So my term-to-term rule is what? Everyone see that? So what do I do with the plus 3? What does the plus 3 give me? Good. Gives me 3n. However, I've got 3, but I want
5, so you need to add 2.
Can everyone see what we're doing here? Yeah? So the term-to-term rule of plus 3 multiplies n. So plus 3 times n is 3n. Because when I put the number 1 in there, I end up with 3 as my first term. I don't want 3, I want 5. So I need to add an adjustment to get from 3 to 5. So I needed to add 2. So I have 3n plus 2. Let's check it with our fifth term. I put the number 5 in here. 3 times 5 is 15, plus 2 is 17. it works. If I wanted to know what my 50th term was, I wouldn't have to write 50 numbers out. I would swap the n for 50, 3 50s or 150, plus 2, 152 is waiting for me at that 50th term. And that's the beauty of this. You can go to any position within a sequence and pull out a value without having to write the sequence out in full. Okay? So, our definition to define a linear sequence means we have to take the second part of our rule, which is do this correction. So, have a look at these sequences and tell me what the nth terms are. First one then. How do I get my nth term from it? What's my rule?
Plus 4.
So what does that give me as far as my nth term is concerned? And what's my adjustment?
Plus 1.
Everybody get that? So that is the expression that defines that sequence. So if I go to my fourth term in my sequence, 4 times 4 is 16, plus 1, 17. I want my 50th term. 4 50s are 200, plus the 1, 201. Easy peasy, isn't it? Let's look at this sequence then, 7, 11, 15. So what's my term to term?
4.
Plus 4. So I've got 4n again. What's my adjustment?
Plus 3.
Plus 3. Good. Okay. Again, if I want my fourth term, 4 4s are 16, plus the 3, 19. The next one, slightly trickier. Got 3 to 11, so that's...
8.
So it becomes...
8 and 8.
And then how do I get from 8 to 3?
Minus 5.
Minus 5. Good. Everybody get those? Kind of, these are your bog standard expressions for sequences. And they might go on and say, what's the 50th value? And you just swap n for the number 50. Okay? These are the harder ones. These are kind of the difference between the C grade and the D grade, really. Let's go through them, slow time, talk about them, see if anybody can do them. So the first one then, what's my approach to that one? Anyone do that one?
Minus 4.
Everyone see it's minus 4. So what does that give me with my n?
Minus 4. And
Perfect. So you leave the minus in there. That's really important. Okay? So what's my correction then? I'm at minus 4 and I need to be at 16.
I've got a positive 20.
Perfect.
I don't know whether that was right.
Okay? So my term to term rule is minus 4. So my rule multiplies n. So it's minus 4n. I'm on my number line. I'm at minus 4 and I need to get to positive 16. So I'm going that way, so I'm adding, and to get from minus 4 to 16 I need to add 20. So if you just stick with the process, it shows you it's minus 4n plus 20. Let's have a look at the fourth term. Minus 4 times 4 is minus 16. Minus 16 plus 20 is positive 4. Works. If I wanted to know what the 50th term was, minus 4 times 50 is minus 200. Minus 200 plus 20 is minus 180. I don't have to write all the terms down. Okay? I just do a bit of substitution. The next one then looks tricky because I've introduced decimals, but it isn't. It's still straightforward. So what's my term to term rule? Plus 2. Plus 2. Okay?
Yeah.
So my term to term rule is plus 2. So it becomes...
And 2.
Everyone happy with that bit? Yeah? So I was just adding 2, so it's plus 2. That's my rule. My rule multiplies n. 2n. I'm at 2, but I don't want 2. I want 1.1. So what do I have to do to get from 2 to 1.1? Minus 0.9. And that is the expression that defines that. So if I say, what's my fourth term? 4 times 2 is 8. 8 take away 0.9 is 7.1. Lo and behold, it's 7.1. Okay? Let's look at the last one then. Minus 11, minus 7, minus 3, and 1. So I'm at minus 11. And I'm going to minus 7.
Adding.
I'm adding 4. So it's 4n. I'm at 4, but I need to be at minus 11. What do I need to do? Minus 15. Good. See how our negative numbers are kicking in? Yeah? Yeah. Okay, so that's kind of the second objective done. So the basic expression to define something in terms of n is multiply n by the rule and then adjust it for the first term. Either add or take away whatever you need to get from your rule to your first term. Right, let's move on to the new bit. This bit of checking what the position value is, in other words, swapping n for a value, is quite important to us in maths, in science. Okay, so we need to start looking at substituting the letter n for our positional value. So if I said to you, I have a sequence 3n plus 4, what is my 10th term? What value do I expect to see when I get to position 10 in my sequence? Yeah, and how did we get that, James? So 3 times 10, so I just swap my positional value for the number 10, gives me 30, and I add the 4. So it gives me the value at 34 in position number 10 in my sequence. Perfect. What they can ask you to do, I've seen it once, maybe twice in 5 years, is they can give you an nth term. So you're not having to work out the nth term, they're giving you the nth term, and they quite simply want you to work out the first, second, third, fourth term in that sequence. All you need to do is swap the letter n for the numbers 1, 2, 3, 4 and so on. So if we've got an nth term, 3n minus 4, you should now be able to recognise it as an nth term, and alarm bells start ringing, I need to do some substitution. So if they want to know the first term, what would I do? Good, so it becomes 3 times 1 is 3, minus 4 is? Good. I put 2 in, 3 2s are 6, minus 4 is 2, so can you see what I'm doing? I swap the n for the third position, 3 3s are 9, minus 4 is 5, and then you end up with 8 and 11. Okay? Everyone happy with how to go from an nth term to the numbers in your sequence? So we're kind of flipping what we did yesterday. Yesterday we had the sequence and worked out the nth term. Today we're just doing it the other way around. If they give us the nth term, I can work out the numbers in my sequence by swapping the letter n for the positions in our sequence. Okay? So, write down the first 4 terms of this sequence and just tell me what the 30th term is. Okay? Most people are getting on with it. So what are my first 4 terms of the sequence? What's my first term?
Just 2 times 1.
Good, 2 times 1 is 2. Minus 1 gives me 1. So my first term is 1. My second term? 3. So I've got 1, 3, 5 and 7. So what would be my 30th term if I just leapt to 30? Yeah, so 2 times 30 gives me 60, minus a 1. My 30th term, straight to it, I know the number 59 is there waiting for me. Yeah, really important thing with sequences. Good. So now we can work out from just the first couple of terms in a sequence what is at any points within a sequence. So in the real world, when we're talking about things like DNA, and we know the sequence, we know the pattern, that's what DNA is, medically you can just jump to any point in that sequence and expect to find a particular value there. So you know if somebody has a deficiency or blue eyes or brown hair or whatever, based on the values when you jump to that point, okay? So, just testing how far you've come then. I'm going to throw a sequence at you, and I want you to tell me what the 102nd term of that sequence is. So you're doing quite advanced stuff now. I've just thrown 4 numbers at you for a sequence, and you're going to tell me what the 102nd... What was your first step? What did you do first?
Plus 4. You
Sorry?
work out the difference.
To work out the difference, which is
Plus 4.
plus 3.
Plus 3.
Yeah. So what does that give us?
3.
And then our adjustment.
Plus 1.
Everyone get that. So that's the nth term that defines it, and then all I need to do to get to my 102nd term.
3 times.
So that gives me 306,
Then you add 1.
and then you add 1. So without having to write that out 100 times in 2 minutes flat, you've gone to the 102nd term and you've worked out that the value at that place is 307. Yeah? See how useful it is? Okay, What we're going to move on to now is something new. And what we're going to show you is that it's quite easy to work out if a number is part of a sequence or not part of a sequence. And it's another one of their favourite questions, okay? So all we need to do is turn our nth term from an expression into an equation. So an expression doesn't have an equal sign, which is what we've been doing for our nth term. All we need to do is work out an equation with the number we've been given. So for example, is the number 66 part of that sequence? Well, I could write that sequence out until I get to around 66 to see if it works. We're better than that now. All we need to do is start by writing down the nth term. So let's write down the nth term for this sequence. So what have I got there? 6n.
Minus 3.
Good. Minus 3. Everyone happy that that is our expression that defines our sequence. So it's our nth term. Okay, nth term is an expression. When they give you a number and they say, is this number part of the sequence? If it's part of a sequence and when we come to solve the equation, so our number we're checking is 66, so we create an equation out of it. When you solve this equation, does it look familiar? Last week, the week before, two-step equations, did them to death? Yeah?
Plus 3.
Yeah? Good. So we know how to solve them. When we solve it, if it doesn't divide neatly, in other words 10 times, 11 times, 12 times, we know it's not part of our sequence. If it's 12.4 times, it's not part of the sequence. It has to be an exact number for n. So let's try that. So two-step equation, we add 3 on both sides. So I've got 6n equals 69. Okay? Divide both sides by 6. N goes into, let's look at 6 into 69. 6 goes into 6 once, 6 goes into 9 one times, remainder 3. So if there's a remainder, it doesn't work. So it's not part of the sequence. So the number 66 is not part of this sequence. Can you see what we've done there? So all you need to do is work out the nth term for the sequence and then solve the equation. Yeah? So turn it into an equation saying it's equal to whatever that number is, and then you can solve it. Okay? Now when we do that, we can do that for images as well. Okay? So everything you've learned yesterday and today about sequences applies to pictures, and they love giving you diagrams of matchsticks or pipes when they connect pipes to do things, because they create patterns, and patterns are sequences. Okay? So if we look at this diagram, typically they would say, you know, what is the nth term expression for this image? And then they'll say, how many matchsticks do you need for the 50th image? So let's look at it. So what was the golden rule yesterday for dealing with images? How do we deal with an image? Yeah, make it into a number, count how many sticks there are. So let's pretend these are matchsticks. So in this image I've got 4. This one I've got 4 plus another 3 is 7. Can you see what I've done there? So that's got 4 matchsticks. They're my original 4, so I'm adding another 3. Here I've got my original 7. I'm adding another 3, so I've got 10. So we're converting images into numbers. So now I've got my numbers. What's my nth term?
Plus 3.
Good. So my rule is plus 3.
On 1.
So my nth term becomes 3n plus 1. So the expression, the nth term for this series of images is 3n plus 1. So if I say, so let's say I want to look at the 20th image. So I've got the first image, second image, third image. I need to know how many matchsticks I need for my 20th image. All you need to do is swap n for 20. 3 times 20 is 60 plus the 1. So I know I need 61 matchsticks for my 20th image. See how that works? Okay. Good. Let's look at images. We're just going to concentrate on images for 10 minutes, okay? So how many stones will the 15th diagram contain? So these are paving slabs. Somebody wants a pattern in their garden. What I want you to tell me is, if I want the 15th image, how many stones do I need for that 15th image? Okay? And I'll let you do that. So there's your images. So the first thing is work out what the rule is. The second thing is work out what the nth term is, and then work out what my 15th image will contain. Right, so let's have a look at it. So what was your first thing that you did? You should talk me through.
Look at the difference.
Good, so what was my difference? How many have I got in here?
1,
1, 5,
9.
9. So
Plus 4.
our rule is plus 4. Good. So my rule is plus 4.
So 4.
So that, as far as the nth term is concerned, is 4n. And what do I need to adjust?
Minus 3.
Everyone happy that they got that as their nth term? Yeah? Yeah, good. And then I said, how many stone slabs do I need for my 15th image?
You times
So-
that by 15.
so that's-
60
Good, so 4 times 15 is 60.
minus 3.
Take away 3 gives me
57.
57. Everyone happy with that? I want you to tell me, for our sequence of stones, which diagram has 33 stones in it. So what do I need to do here? What am I asking you to do? I've got my nth term, which is an expression. If you get given a number of stones, you have to turn it into
2 separate.
good. So
9.
equals 33 stones. Ah, Brittany's done it already. So two-step equation, everyone happy with our two-step equations? We add 3 on both sides. We have 4n equals 36. Divide both sides by 4. And my 9th picture will contain 33 stones. Can you see what we did there? Yeah? So I had my expression, and when they say which picture has 33 stones, or is the number 33 part of the sequence, you convert it into an equation. Okay? So there you go. It's another one for you. And this is another one of their favourite things. These are white bars, or think of them as matchsticks if you want. So how many sticks have I got in the first one? I gave you that one, didn't I? 6. The next one? 11. And the next one?
16.
16. Don't really need to do the third one, do you? Because you just need 2. Right, so what's my term-to-term rule?
Plus 5.
Plus 5. So what does that give me for an nth term?
5 and plus 1.
Everyone happy with that as your nth term? And then you say, I'm looking for the 20th pattern. So all we need to do, swap n for 20, gives me 100, plus the 1. I need 101 matchsticks, poles, whatever they are, for my 20th pattern. Yeah? See how that works? Excellent. There you go. Which pattern will contain 61 bars? I'll tell you what, I'll give you the nth term because you've already worked it out. So there's your nth term. Which pattern will contain 61 bars? Let's do this. So what do I have to do to prove which one has 61?
You put 61 in.
So we turn it into an equation to prove that 61 bars is part of it. Well, as soon as I do that, alarm bells start ringing. Two-step equation. Step 1,
Minus 1.
take away the 1. 5n equals 60. Step 2,
Divide
5 by 5. And n equals 12. So my 12th pattern will contain the 61 bars. Brilliant. Good, good, good. Okay, I'm going to give you a couple of exam style questions to finish off. Right? So, first question, here are the first 3 terms of a sequence. Basically, for 1 mark, they want you to circle the correct nth term. You write it down for me. So 1, 4, 7. What is the nth term for the sequence 1, 4, 7, 10? So what did we come up with our nth term?
3n minus 2.
Yeah? Happy with that? So the rule was plus 3, as Brittany says, which gives us 3n, and then our adjustment from 3 to there, minus 2, and as Ali says, you would circle that 1 mark in the back. Question 6 had this sequence, 1, 6, 16. The rule of the sequence is double the previous term and add 4. So it's a non-linear sequence. Work out the next 2 terms in the sequence. So nice and straightforward. So this is that exam paper that I handed to you to go away and look at. So you're starting at 16, it says double the previous term, so you multiply it by 2 to get 32, and then you add 4 to get 36. You then have 36, which you need to double, which is 72, add 4, which is 76. Happy?
Oh yeah.
Yeah? If you don't do that, you've thrown one of the 2 marks away. They give you the old famous pattern using matchsticks thing, okay? So there's our pattern. And what they're saying is complete the table for the pattern. So it goes 5, 9, 13, and for 1 mark, you've just got to continue the sequence. So what's our term-to-term rule? So it goes, so for 1 mark, you have to add 4 and then add 4 again and complete the table, okay? Everyone happy that you can do that now with an image into numbers, okay? It then says, work out the nth term of the sequence, 5, 9, 13. This is 2 marks. So, what's our nth term? Good, so my rule is +4. I'd show the examiner +4 as my rule. So I would go 4n, and then my adjustment of +1. So I'd go from that to that, and I'd just say +1 or something, just to show him a little bit of working out. Okay? If you wanted to, you could write the rule is +4, therefore 4n, and put it in longhand. 4n + 1. You need to write it on here to get that second mark. Okay? So you need some kind of working out to show him what you're doing. So the term-to-term rule is +4. That becomes 4n, and then you adjust with the +1. Okay? Which pattern is made using 53 sticks?
273.
Good. So what does it become?
4 plus 1 equals 53 minus 1.
4 into 5. Remainder. 4 into 12. Happy? I've got 39, 47 and 55 are the 5th, 6th and 7th terms in a sequence. What is the first term and what is the nth term? I'm just going to shrink this writing down so I can write something under it. Okay, so very nice, very neat indeed. James, tell the class what you did. I'm so chuffed with it. It's a really good solution. So what did you do then?
Worked out the nth term first.
Good. So the term-to-term rule. And the term-to-term rule was +8. Everybody happy with that? Yeah? So what that gives you, as far as your nth term is concerned, is 8n. Happy with that? That wouldn't differ at all.
Plus 39 is the 5th term, 8 times 5.
Good. So what he said then was, my 5th term, I know what my 5th term is, so 8 times 5 is 40. I need to do an adjustment to get from 40 to 39, because that's his 5th term. He knows it's the 5th term. So he said I need to minus 1. So he minus 1 to get his 39. So you now know that your nth term is 8n minus 1. So we actually worked out the nth term first, which is brilliant. And then to find your first term, just swap the letter n for the number 1. First term is the number 7. Okay, so that's our third and final objective. So between yesterday and today, we've kind of done sequences today. We can continue sequences, whether they're linear or non-linear. For non-linear sequences, we also know how to follow functions, as in multiply by 2 plus 4. To come the other way, we minus 4 and divide by 2. Okay? Linear sequences were the main flavour of today, and that is how to get a linear sequence and define it in terms of n. So you look at the rule, multiply n by the rule, and then do the adjustments. If they say, is a number part of a sequence, you turn the expression, the nth term, into an equation. If they're trying to find out how many things are in a pattern, you do substitution. So position number 10, you swap the letter n for the number 10.